November 1941. Bureau of Ships, Washington, D.C. The blueprint rolled across the conference table showed specifications that violated every principle Commander John Vickery had learned in 20 years of naval architecture. The document demanded a vessel that could cross oceans like a cargo ship, fight like a warship, and drive nose first onto hostile beaches like nothing that had ever existed. The requirements were simple to state and impossible to achieve. The vessel must carry a 60-ton tank, the new M4 Sherman, and drive directly onto an unimproved beach through 3 feet of water. It must have ocean-going capability to cross the Atlantic or Pacific. It must have a shallow enough draft to approach beaches that would ground conventional ships hundreds of yards offshore. It must open its bow, not its stern, allowing tanks to drive off facing the enemy rather than reversing into gunfire. The contradictions were obvious to anyone who understood ships. Ocean-going vessels required deep drafts for stability. Shallow draft vessels capsized in open water. Bows strong enough to ram beaches could not have doors cut into them without catastrophic structural failure. Vessels that could carry 60 tons could not operate in 3 feet of water. Every requirement conflicted with every other requirement. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. Vickery stared at the specifications, knowing that men would die if his team failed. Not might die. Would die. The British had learned this lesson bloodily at Dunkirk, where 338,000 men were evacuated, but virtually all heavy equipment was abandoned because no vessels existed to carry tanks off beaches. The British were learning it again in commando raids, where inadequate landing craft meant trapped soldiers and mission failures. The military situation was deteriorating rapidly. German forces controlled Europe from Norway to Greece. Japan was mobilizing across the Pacific. British Prime Minister Winston Churchill was demanding landing craft, thousands of them, for operations he would not yet specify, but everyone understood meant massive amphibious invasions somewhere, sometime, against defended beaches. The United States was not yet at war in November 1941, but war was coming. Everyone in the Bureau of Ships knew it. The question was whether American industry could design and build the vessels needed for amphibious warfare before those vessels were desperately required in combat. Sitting beside Vickery was John C. Niedermayer, a naval architect who had spent 15 years designing conventional cargo ships. Niedermayer understood that conventional solutions would not work. A cargo ship's hull was designed to carry weight deep in the hold with the center of gravity below the waterline. The new vessel would carry tanks on the main deck, raising the center of gravity dangerously high. A cargo ship's bow was designed to cut through waves. The new vessel's bow must open completely, eliminating structural strength at the ship's most critical stress point. The British had already attempted a design, the Landing Ship Tank Mark II, but British shipyards were overwhelmed. They were building destroyers, corvettes, minesweepers, cargo ships, everything needed to fight Germany's U-boat campaign. They could not also build hundreds of specialized landing ships. That task would fall to American shipyards, which meant American engineers must refine the British design or create something entirely new. The timeline was equally impossible. The Joint Chiefs of Staff wanted production vessels within 6 months. 6 months to design a ship type that had never existed. 6 months to solve engineering problems that violated basic physics. 6 months to create manufacturing specifications, train workers, and begin construction. Vickery knew the cost of failure. Inadequate landing craft meant soldiers drowning in deep water. Trapped vehicles meant slaughter on beaches. Structural failures meant ships sinking with tanks and men aboard. Every design decision would be written in blood on some future beach. The meeting adjourned with assignments distributed. Niedermayer's team would tackle hull design. Other teams would address propulsion, ballasting, bow doors, accommodations. They had until May 1942 to produce a final design. 5 months to create what many believed was impossible. What none of them knew was that their work would produce 1,051 vessels that would carry millions of tons of cargo, land hundreds of thousands of troops, and make possible every major amphibious operation in Europe and the Pacific. The need for landing ships capable of carrying tanks had been written in British blood across 3 years of desperate operations. The lesson began at Dunkirk on the beaches of northern France between May 26 and June 4, 1940. 338,000 British and French troops were evacuated from Dunkirk in Operation Dynamo, one of history's most successful rescues. But success concealed a catastrophic failure. The British Expeditionary Force abandoned virtually every piece of heavy equipment in France: 2,476 guns, 63,938 vehicles, 20,000 motorcycles, 8,000 Bren guns, 90,000 rifles, and 7,000 tons of ammunition, and approximately 440,000 tons of stores and supplies were left behind. Most critically, all tanks were abandoned, not because they were destroyed, because no vessels existed to carry them off beaches. Destroyers and civilian boats could evacuate men by bringing them aboard over the side. They could not embark a 28-ton Matilda tank. The British Army returned to England, with its soldiers, but without the equipment those soldiers needed to fight. Winston Churchill, newly appointed Prime Minister, understood immediately that Britain could never invade occupied Europe without the capability to land tanks directly onto hostile beaches. He began demanding landing craft with the obsessive focus that characterized his wartime leadership. In a memo dated June 26, 1940, just weeks after Dunkirk, Churchill wrote to the Chiefs of Staff, demanding that arrangements be made to construct landing craft capable of carrying tanks. The British developed several landing craft designs rapidly. The landing craft tank carried 4 tanks, but could not cross oceans under its own power. It required transport ships to carry it to invasion sites. The landing ship Tank Mark I was a converted tanker with a large opening cut in the bow. The design worked poorly. The ship was slow, unstable, and the bow opening weakened the hull structure. British commandos conducted raids to test landing craft and gather intelligence. Operation Claymore in March 1941 targeted the Lofoten Islands in Norway. The raid succeeded, but getting tanks ashore proved difficult. Operation Archery in December 1941 hit Vagsø, Norway. Again, landing heavy equipment was problematic. The raids demonstrated that current landing craft were inadequate for opposed landings against defended beaches. The bloodiest lesson came at Dieppe on August 19, 1942. Operation Jubilee was planned as a raid in force to test amphibious assault tactics and capture a port temporarily. 6,000 troops, predominantly Canadian, assaulted the French coastal town of Dieppe. 29 Churchill tanks accompanied the force. The operation was a catastrophe. German defenders were alert and well positioned. The tanks landed but could not advance beyond the beach due to sea walls and obstacles. Without tank support, infantry were pinned down by machine gun fire. Of the 6,000 troops landed, 1,000 were killed and 2,000 taken prisoner. 60% casualties. All tanks were lost. Dieppe demonstrated conclusively what happened when landing craft could not deliver tanks effectively onto hostile beaches. Soldiers died. The operation's after-action reports emphasized repeatedly that future invasions required landing ships that could drive directly onto beaches, rapidly discharge tanks, and provide those tanks immediate access to exits from the beach. The British had begun developing the landing ship Tank Mark II in 1941. The design addressed some problems. It was purpose-built rather than converted. It had bow doors allowing tanks to drive off directly. It could cross oceans under its own power. But British shipyards could not build them in necessary quantities while also constructing escorts and cargo ships for the Battle of the Atlantic. That problem landed on American desks in November 1941. The British provided their Mark II plans to the United States Navy. American engineers were tasked with refining the design and mass-producing it. The timeline was impossible. The specifications contradicted basic naval architecture. But the alternative was measured in dead soldiers on future beaches. The lessons were clear. Dunkirk taught that armies without heavy equipment could not fight. British raids taught that inadequate landing craft meant mission failure. Dieppe would soon teach that tanks trapped on beaches meant slaughter. Someone had to design a ship that solved all these problems. They had 5 months. January 1942, Bureau of Ships, Washington, D.C. John C. Niedermayer spread the British LST Mark II blueprints across his drafting table and began identifying every problem that would kill American soldiers if left unsolved. The British design was functional but crude. Niedermayer's team had 5 months to transform it into something that could be mass-produced by shipyards that had never built anything like it. The engineering challenges were fundamental contradictions in physics. A ship with shallow draft lacked the deep keel necessary for ocean stability. A ship with bow doors had structural weakness at the point of maximum stress. A ship carrying tanks on the main deck had a dangerously high center of gravity. A ship that could beach itself could not easily unbeach itself. Every solution created new problems. Commander John Vickery assembled a team of naval architects who understood they were designing a vessel that violated conventional wisdom. Present were men from the Navy's Bureau of Ships, representatives from the Maritime Commission, and engineers from the British Admiralty, who had struggled with these same problems for 2 years. The British shared everything they had learned, including their failures. The first problem was draft. A 60-ton Sherman tank required a vessel with substantial displacement, which meant deep draft for stability. But approaching a beach meant operating in 3 feet of water or less. The contradiction was absolute. Heavy vessels drew deep. Shallow draft vessels could not be heavy. Niedermayer proposed a radical solution: variable ballast tanks integrated throughout the hull. At sea, the tanks would be flooded with seawater, lowering the center of gravity and increasing draft to approximately 14 feet. This provided stability for ocean crossings. Approaching a beach, pumps would empty the tanks, raising the ship until it drew only 3 feet 9 inches forward and 9 feet 6 inches aft. The ship could literally adjust its own displacement based on operational requirements. The ballast system was unprecedented in naval architecture. It required pumps powerful enough to move thousands of tons of water in minutes. It required tanks positioned to maintain proper trim as they flooded or emptied. It required crews trained in ballasting procedures that no sailors had ever performed, but it solved the impossible draft problem. The second problem was the bow. Ships' bows are designed for strength. They smash through waves in storm conditions. Cutting a massive door into the bow eliminated structural integrity at the ship's most stressed point. The British Mark II had bow doors, but they leaked constantly and weakened the hull. Niedermayer's team designed a bow ramp system with 3 components. The outer bow doors consisted of 2 steel plates hinged at the sides, opening outward like French doors. Behind them, a ramp lowered to bridge the gap between ship and shore. The ramp was supported by cables and could adjust to different beach slopes. When closed and locked, the bow doors and ramp created a watertight seal, reinforced by extensive bracing. The key innovation was making the bow stronger when closed than conventional bows. Additional structural members tied the bow doors into the hull framework. The door locking mechanism used massive steel bars. When locked, the bow could ram obstacles and absorb punishment that would damage conventional vessels. The third problem was the flat bottom. Ocean-going ships have curved hulls that slice through waves. Niedermayer's LST had a completely flat bottom from bow to stern. This made the ship slam violently in heavy seas, creating brutal conditions for crew and cargo. But the flat bottom was essential for beaching. Any curve in the hull meant the ship would settle into sand unevenly and potentially roll. The team accepted that LST crews would experience rough rides. They compensated by strengthening the hull to absorb the pounding and designing cargo, securing systems to prevent tanks from breaking loose in storms. Telling and preparing this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. By May 1942, the design was finalized. The LST would be 328 feet long, 50 feet wide, displacing 4,080 tons fully loaded. It could carry 20 Sherman tanks, or 2,100 tons of cargo. 2 grey marine diesel engines would provide 2,400 horsepower, giving a maximum speed of 12 knots. The crew would be 113 officers and enlisted men. Niedermayer had solved the impossible specification in exactly 5 months. The design existed on paper. Now someone had to build 1,051 of them. September 1942, Evansville, Indiana. The keel of LST-157 was laid at a shipyard that had not existed 6 months earlier, in a city 640 river miles from the nearest ocean. Around the keel, workers from automobile factories, steel mills, and farms were building an ocean-going vessel none of them had ever seen except in photographs. The decision to build LSTs inland was born from desperation and geography. Coastal shipyards were overwhelmed, building destroyers, cargo ships, and tankers. The Navy needed hundreds of LSTs immediately. The solution was to build them on rivers flowing to the sea, then sail them downstream to the ocean. The concept was simple. The execution required building shipyards from nothing in landlocked communities. The inland shipbuilding program focused on rivers connected to the Gulf of Mexico. The Ohio River flowed into the Mississippi, which flowed to the Gulf. Cities along these rivers had steel mills, manufacturing infrastructure, and available labor. They had no shipbuilding experience whatsoever. Evansville, Indiana became the largest LST production center. The Missouri Valley Bridge and Iron Company, which had built bridges across the Midwest, was contracted to build LSTs. The company had never built a ship. Within 6 months, they constructed a shipyard from bare ground, trained thousands of workers, and began producing LSTs. The workforce was entirely unconventional by naval standards. Bridge builders who understood steel, fabrication but not naval architecture, automobile workers from Detroit who understood assembly lines but not ships, welders from construction sites, farmers who needed wartime employment, women entering manufacturing jobs for the first time. Almost none had seen the ocean. Training programs were established rapidly. Experienced shipwrights from coastal yards were brought inland to teach basic skills. The Navy assigned officers to supervise construction and ensure vessels met specifications. Workers learned by doing, making mistakes on early hulls and refining techniques on later ones. The production process borrowed heavily from automobile manufacturing. LSTs were built using assembly line techniques unprecedented in shipbuilding. Prefabrication meant components were manufactured in different locations and transported to the shipyard for assembly. Engines were installed as complete units. Entire sections of hull were welded together away from the slipway, then lifted by cranes into ditchery position. This modular construction method dramatically accelerated production. Early LSTs took 5 months to build. Within a year, construction time dropped to 2 months per vessel. At peak production, Evansville was launching an LST every 3 days. Other inland shipyards followed similar patterns. The American Bridge Company in Ambridge, Pennsylvania, built LSTs on the Ohio River. Chicago Bridge and Iron Company constructed a shipyard in Seneca, Illinois, on the Illinois River. Jeffersonville Boat and Machine Company in Jeffersonville, Indiana, expanded from building small craft to building LSTs. The strangest shipyard was in Pittsburgh, Pennsylvania. Dravo Corporation built LSTs at Neville Island, 60 miles from downtown Pittsburgh. The ships were launched sideways into the Ohio River because the river was narrower than the ships were long. Launching an LST sideways created massive waves that flooded riverbanks. Schedules were coordinated with river traffic to avoid swamping. Smaller vessels. Workers faced unique challenges. Welding hull plates in Midwestern winters meant working in temperatures far below freezing. Installing equipment in summer heat inside steel hulls created oven-like conditions. The work was dangerous. Welders were burned. Workers fell from scaffolding. Heavy equipment crushed fingers and hands. But production continued without pause. By December 1942, the first inland-built LSTs were sliding down rivers toward the ocean. LST 157 from Evansville traveled the Ohio River to the Mississippi, then down to New Orleans. The voyage took 2 weeks. The ship had never been in salt water. The crew had trained on rivers. They were now sailing to war. The inland shipbuilding program would eventually produce over 500 LSTs, more than half the total wartime production. Bridge builders and automobile workers had become shipbuilders. Cornfields and steel mills had become naval arsenals. The impossible was being built in places that should never have been able to build it, by people who should never have been able to do it. The LSTs floated. They sailed. And very soon, they would go to war. October 14th, 1942, Newport News, Virginia. USS LST-1 was commissioned into the United States Navy, the first of a vessel type that existed nowhere else in the world. Within hours, the ship departed for Chesapeake Bay to begin sea trials that would determine if Niedermayer's design worked or if 1,049 additional LSTs already under construction would need radical modifications. Commander J.E. Fitzpatrick assumed command of LST-1 with a crew that was still learning what their ship could do. The vessel's official designation was landing ship, tank. The crew called it Large Slow Target because the flat-bottomed hull slammed through waves at a maximum speed of 11 knots, making it easy prey for submarines and aircraft. The nickname would prove grimly accurate. The first problem appeared within hours. In Chesapeake Bay's moderate seas, LST-1 rolled violently. The flat bottom and high center of gravity created a motion unlike any cargo ship or warship. Crew members became seasick in conditions that would not affect conventional vessels. Equipment broke loose. The ship felt unstable, as if it might capsize in a strong wind. The Bureau of Ships had anticipated this. The design included ballast tanks specifically to lower the center of gravity at sea. But the ballasting procedures were complex. Flood the tanks too quickly, and the ship's trim became uncontrollable. Empty them too slowly, approaching a beach, and the LST would ground too far from shore. Fitzpatrick's crew spent weeks mastering the ballast system, learning through trial and error how to adjust the ship's displacement for different conditions. The bow doors leaked, not catastrophically, but constantly. Seawater seeped through the seals where the massive steel doors met the hull. Pumps handled the leakage, but in heavy seas, water entered faster than pumps could remove it. The forward tank deck, where vehicles were stored, was perpetually damp. Salt water corroded equipment. Tank crews discovered their vehicles needed constant maintenance to prevent rust. The steering system proved inadequate. LSTs used a conventional rudder, but the flat bottom and shallow draft meant the rudder had minimal effect at low speeds. Maneuvering in harbors was difficult. Approaching a beach in surf required skill and luck. If the LST hit the beach at the wrong angle, it could broach, turning parallel to the shore and becoming stuck. Engineers modified the design continuously during 1942 and 1943. Improved bow door seals reduced but never eliminated leaking. Additional ballast tanks were installed to improve stability. The rudder was enlarged slightly. Propellers were redesigned for better low-speed maneuverability. Every modification was incorporated into LSTs under construction, creating minor variations between early and late production vessels. The most significant challenge was simply learning to operate these ships. The Navy had no training program because the vessel type was new. Fitzpatrick and his crew wrote the operating manual as they discovered what worked. They documented ballasting procedures, beaching techniques, cargo loading methods, and emergency protocols. Their experience became the foundation for training crews of subsequent LSTs. By December 1942, LST-1 had proven the design was functional. The ship could cross oceans, albeit slowly and uncomfortably. It could approach beaches and lower its bow ramp. It could embark and disembark tanks under controlled conditions. Whether it could do these things under enemy fire remained unknown, but the design was sound enough to proceed with mass production. Production accelerated dramatically through 1943. The initial construction time of 5 months per vessel was applied. Unacceptable. The Navy needed hundreds of LSTs immediately. Shipyards implemented assembly line techniques borrowed from automobile manufacturing. Prefabrication meant major hull sections were built separately and welded together on the slipway. Engines, generators, and other equipment were installed as complete units, rather than assembled piece by piece aboard the ship. By mid-1943, construction time had dropped to 2 months per vessel at efficient yards. Some yards achieved even faster production. The record was held by Chicago Bridge and Iron Company in Seneca, Illinois, which launched an LST every 23 days at peak production. The numbers told the story. In 1942, 34 LSTs were commissioned. In 1943, 388 were commissioned. In 1944, 489 were commissioned. By war's end, in August 1945, 1,051 LSTs had been built at shipyards across the United States. The cost was equally remarkable. Each LST cost approximately $1,600,000, including equipment and armament. By comparison, a Baltimore-class heavy cruiser cost $53 million. A Fletcher-class destroyer cost $6 million. Even a Liberty ship cargo vessel cost $2 million. The LST delivered immense capability for minimal investment. The cost efficiency came with trade-offs. LSTs were uncomfortable. The flat bottom meant violent motion in any seaway. Crew quarters were cramped. The ships were noisy, with diesel engines roaring constantly. They were slow, making 11 knots maximum speed when other warships made 30 knots or more. They were vulnerable, with minimal armor and light defensive armament, but they carried tanks. 20 Sherman tanks, or 163 soldiers with equipment, or 2,100 tons of cargo. They could drive onto hostile beaches and discharge directly onto sand. They could retract from beaches under their own power. They were the only vessels in the world capable of delivering heavy equipment directly into combat without requiring port facilities. Training crews became a massive undertaking. The Navy established LST training schools at several locations. Experienced crews from early LSTs were rotated back to train new crews. Training covered not just seamanship but also cargo handling, beach operations, damage control, and combat procedures. Crews learned to operate in conditions no previous sailors had faced, approaching hostile shores while loaded with explosives and gasoline. By June 1943, dozens of LSTs were gathering in North Africa for the largest amphibious operation yet attempted. The prototypes had become a fleet. The experimental design had become the foundation of Allied amphibious strategy. The vessels built by bridge workers in cornfields were about to prove they could fight. LST-1 and would survive the war, participating in operations from North Africa through the Pacific. The ship was decommissioned in 1946 and sold for scrap in 1948, but by then, 1,050 more LSTs were carrying the war to hostile shores, delivering tanks and troops where no other vessel could reach. Niedermayer's impossible design had become the weapon that made amphibious warfare possible. July 9, 1943, Mediterranean Sea. 229 LSTs were crossing from North Africa towards Sicily in the largest amphibious invasion yet attempted. Each ship carried Sherman tanks, trucks, ammunition, fuel, and soldiers. The vessels were loaded beyond peacetime safety limits because everything they carried would be needed immediately when the invasion began. Operation Husky was designed to capture Sicily and open the Mediterranean to Allied shipping. The island was defended by 230,000 Italian troops and 40,000 German troops dug into prepared positions. The invasion force consisted of 160,000 American and British troops who would assault beaches on the southern and eastern coasts simultaneously. The LSTs were essential. Previous amphibious operations in North Africa had been limited by the inability to land tanks quickly. At Casablanca in November 1942, tanks were landed using improvised methods that took hours. At Sicily, planners expected to land 300 tanks in the first wave using LSTs that would drive directly onto beaches and discharge in minutes rather than hours. The crossing from North Africa took 2 days. The LSTs wallowed through moderate seas at 9 knots, their maximum speed while fully loaded. Below decks, tank crews tried to sleep despite the ship's violent motion. The flat bottom slammed through each wave, creating noise and vibration that made rest impossible. Diesel fumes from the engines permeated every compartment. Seasickness was epidemic. German and Italian reconnaissance aircraft spotted the invasion fleet on July 8th. Luftwaffe and Regia Aeronautica bombers attacked repeatedly during the approach. LSTs, slow and unarmed except for anti-aircraft guns, were priority targets. The ship's crews manned their weapons continuously, firing at high-altitude bombers and low-flying torpedo planes. Several LSTs were damaged. LST 313 was hit by a bomb that penetrated the tank deck and exploded among vehicles, killing crew and soldiers. The ship survived and continued toward Sicily. The weather deteriorated on July 9th. Winds increased to 35 knots. Waves reached 15 feet. The storm was strong enough that some commanders recommended postponing the invasion. General Dwight Eisenhower, Supreme Allied Commander, decided to proceed. The fleet was committed. Turning back would alert the enemy and waste months of preparation. The invasion would go forward regardless of weather. The storm actually helped the Preußenstadt allies. Italian coastal defenders assumed no invasion would occur in such conditions and relaxed their vigilance, but the storm made landing operations far more difficult. LSTs approaching beaches in 15-foot surf and high winds struggled to maintain course. Several ships broached, turning parallel to the shore. Crews fought to maneuver their vessels, using engines and rudder together to force the bows toward the beach. At 02:45 on July 10, 1943, the first LSTs hit the beaches. The timing was coordinated across multiple beaches spanning 100 miles of coastline. American forces landed at Licata, Gela, and Scogliti. British and Canadian forces landed at Pacino, Avola, and Syracuse. LST 325 approached Gela Beach carrying 16 Sherman tanks of the 2nd Armored Division. The ship's commanding officer, Lieutenant James R. Rutter, brought the LST to within 50 yards of shore before the flat bottom grounded on sand. The bow doors opened, the ramp lowered. Rutter gave the order, and the first Sherman rolled off the ramp into 3 feet of water, drove through the surf, and climbed onto the beach. Behind it, 15 more tanks followed in rapid succession. The entire discharge took 12 minutes. Italian defenders opened fire immediately. Artillery shells began falling around LST 325. Machine gun fire raked the beach, but the tanks were already moving inland, their main guns returning fire. The LST retracted from the beach, backing into deeper water using its engines. The ship had been under fire for less than 20 minutes from the moment the bow doors opened until it was back at sea. This was repeated 229 times across Sicily's beaches. LSTs drove onto sand under fire, opened their bows, discharged tanks and vehicles, and retreated to deeper water. Some ships made multiple trips, returning to transport ships offshore to load more equipment, and returning to beaches to discharge again. The system worked, but the cost was real. LST 158 struck a mine while approaching the beach at Gela. The explosion blew a hole in the hull below the waterline. The ship began taking on water faster than pumps could handle. The crew beached the LST deliberately, driving it as far onto shore as possible before it could sink. Tanks rolled off into shallow water and made it to shore. LST-158 would be abandoned, a total loss, but its cargo was saved. LST-313, already damaged by aerial bombing, was hit by artillery while discharging at Licata. A shell penetrated the bow door and exploded inside the tank deck. Fire erupted among vehicles loaded with ammunition and fuel. The crew fought the fire while continuing to discharge vehicles. Several crew members were killed. The ship survived and withdrew under its own power after completing its mission. German defenders counterattacked on July 11th. Panzer units from the Hermann Göring Division attacked American positions at Gela. The defense depended entirely on the tanks that had been landed by LSTs. Sherman tanks engaged German Mark IVs in close-range combat through the town's streets. Naval gunfire from destroyers offshore and direct fire from tanks ashore stopped the German counterattack. Without the rapid delivery of heavy armour, the beachhead would have been overrun. By July 12th, 72 hours after the first landings, 80,000 troops, 7,000 vehicles, and 300 tanks had been landed across Sicily's beaches. The invasion was succeeding. Italian coastal divisions were surrendering. German units were withdrawing toward the northeast corner of the island. Allied forces were pushing inland. The LSTs continued operating throughout the campaign. They transported reinforcements, delivered ammunition and fuel, evacuated wounded. They operated under constant threat from aircraft, submarines, and coastal artillery. 17 LSTs were sunk or damaged severely enough to be withdrawn from service. Casualties among LST crews totaled 137 killed and 218 wounded. But the concept was proven. LSTs could deliver tanks directly onto hostile beaches under fire. The vessels that had been designed in 5 months and built by bridge workers in cornfields had performed exactly as intended. They had changed amphibious warfare permanently. The Italian campaign continued through Sicily and onto the mainland. LSTs participated in the Salerno landings in September 1943 and the Anzio landings in January 1944. At Anzio, LSTs beached repeatedly under German artillery fire, delivering reinforcements to a beachhead that was nearly overrun. The ships absorbed damage, took casualties, and kept delivering tanks. By mid-1944, the LST was the most important amphibious vessel in the Allied arsenal. The ships were ungainly, uncomfortable, and slow. They were called large, slow targets by their crews, but they delivered tanks to beaches where no other vessel could, and tanks on beaches won invasions. The impossible specification had become the weapon that would carry the war to Germany's doorstep. That moment was coming soon, on the beaches of Normandy. June 6, 1944, English Channel. 236 LSTs were crossing toward Normandy, carrying the vehicles and equipment that would determine if the invasion succeeded or failed. Each ship was loaded beyond capacity. Sherman tanks filled the tank decks. Trucks, jeeps, artillery pieces, and ammunition were crammed into every available space. Soldiers slept on tank turrets and between vehicles because bunks were full. The crossing was brutal. Channel seas were rough, with waves reaching 6 feet. The weather had nearly caused General Eisenhower to postpone the invasion. LSTs wallowed through the swells, their flat bottoms slamming into each wave. Crews who had crossed the Mediterranean thought they knew what rough seas meant. The Channel was worse. German E-boats prowled the convoy routes. Mines floated loose from defensive fields. Allied minesweepers had cleared channels, but mines broke free in the storm. LST-499 struck a mine during the approach and sank with casualties. Other LSTs diverted around the wreckage and continued toward the beaches. At 06:30 on June 6th, LSTs began hitting 5 beaches simultaneously: Utah, Omaha, Gold, Juneau, and Sword. Each beach had different conditions, different obstacles, different defenses. The LSTs had to adapt to whatever they encountered. Omaha Beach was catastrophic. German defenders occupied cliffs overlooking the beach. Artillery, mortars, and machine guns created interlocking fields of fire. The first assault waves took terrible casualties. LSTs approaching Omaha could see tracers ripping across the beach and bodies floating in the surf. LST-43 grounded at Omaha at 07:15. The bow doors opened under direct fire. Artillery shells were exploding on the beach. Machine gun fire was hitting the ship's superstructure. The first Sherman tank rolled down the ramp into 4 feet of water. German anti-tank guns found the range. The tank was hit and exploded before reaching dry land. The crew inside died instantly. Behind that tank, 19 more Shermans were waiting to discharge. LST-43's commanding officer had to decide whether to continue or abort. He continued. Tanks rolled off into murderous fire. Several were destroyed on the beach. Others made it to cover and began engaging German positions. LST-43 retracted from the beach with casualties, its mission complete. LST-507 was hit by artillery while discharging at Omaha. A shell struck the tank deck, igniting fuel and ammunition. Fire spread rapidly. The crew fought to control the blaze while soldiers and tank crews evacuated. 31 men died before the fire was extinguished. The ship survived and withdrew. By June 7th, D+1, over 50,000 vehicles had been landed across Normandy's beaches. Thousands came off LSTs that drove directly onto sand, discharged under fire, and withdrew. 26 LSTs were sunk or damaged during the Normandy operation. Casualties totaled over 400 killed and wounded, but the invasion held. Without LSTs delivering tanks and vehicles directly onto beaches, the invasion would have failed. The ships that had been designed in 5 months had proven they could fight the largest amphibious operation in history. The Pacific theater presented challenges that dwarfed Europe. Distances were measured in thousands of miles. Islands had no ports. Reefs prevented conventional ships from approaching shores. Every invasion required LSTs to carry tanks across open ocean and land them on coral beaches under fire. General Douglas MacArthur's island-hopping strategy depended entirely on LSTs. Each captured island became a base for the next operation. But capturing islands required landing tanks and artillery to defeat entrenched Japanese defenders. Only LSTs could deliver that firepower directly onto beaches. At Tarawa, in November 1943, LSTs proved essential. The coral reef prevented conventional landing craft from reaching shore. Marines waded 600 yards under fire, taking terrible casualties. LSTs drove over the reef, grounded on the beach, and discharged tanks that provided the firepower needed to break Japanese defenses. The pattern repeated across the Pacific. Kwajalein in January 1944, Saipan in June 1944, the Philippines throughout late 1944. Each operation required dozens of LSTs making multiple trips, delivering tanks, ammunition, fuel, and reinforcements. The kamikaze threat emerged in October 1944. Japanese suicide aircraft targeted LSTs deliberately. The ships were slow, lightly armed, and loaded with explosives and fuel. A single kamikaze strike could destroy an LST completely. Dozens were sunk. Hundreds of sailors died in fires that consumed ships faster than crews could evacuate. LST-738 was hit by a kamikaze off Okinawa in April 1945. The aircraft struck the tank deck, igniting fuel and ammunition. The explosion broke the ship's back. LST-738 sank in minutes. 143 crew members and soldiers died. But the operations continued. At Iwo Jima in February 1945, LSTs landed tanks under fire from Mount Suribachi. At Okinawa from April through June 1945, LSTs sustained the largest amphibious operation in the Pacific, despite relentless kamikaze attacks. Planning for Operation Downfall, the invasion of Japan, assumed thousands of LST trips would be required. The invasion was expected to be the bloodiest operation of the war. The atomic bombs in August 1945 ended the war before downfall began, but LSTs carried occupation forces into Japan throughout late 1945. The LST's service continued long after World War II ended. The ships fought in Korea from 1950 through 1953. They served in Vietnam. They were transferred to Allied navies worldwide. Some remained in service into the 2000s, 60 years after they were designed. Of the 1,051 LSTs built, 26 were lost in combat. They carried millions of tons of cargo, hundreds of thousands of vehicles, and made every major amphibious operation possible. John Niedermayer and his team had designed in 5 months what would change history. The impossible specification had become the weapon that won the war. The bridge builders and automobile workers who built them in cornfields had created vessels that would serve for generations. The LST was never truly replaced because the design solved problems so fundamentally that no improvement was necessary. Up next, we have 2 more incredible stories that are waiting for you. Just click the image you want to watch and it will take you there. If you enjoyed this video, make sure to subscribe. It would mean a lot.